Hello, periods 1, 4, and 6 math. This is your e-learning day lesson. I suggest that you either take notes in Notability, which means you're going to need some graph paper, or go to your core teacher, whoever that is. They have graph paper available for you. So once you are ready and you have graph paper, I would suggest that you, as we do the problems, you take notes. Occasionally I'll have you stop and actually do practice problems. Okay, here we go. Our topic for today is finding the distance between 2 points on a coordinate plane. And you'll find that there are actually two types of problems, which I will talk about each one in length as we go through the video. For these first couple of slides, you don't need to take notes. I'll tell you when you need to start taking notes. Okay, so as we begin, first of all, this is a coordinate plane, in case you forgot that. So I'm going to show you there are two kinds of problems that we are going to actually do. Okay, if you focus on the two blue points, and if I said for you to find the distance between those 2 points, I'm guessing without my help you could actually tell me the distance between the two blue points. Now, if I asked you to find the distance between the two green points, I would hope you would say, I don't know what it is because it's not a straight line. So we're actually going to solve problems like these differently. So if you look at the blue one, all right, so if the 2 points are actually on the same, they're equal distance from each other and they're a straight line, we do that completely different from when we try to find the distance between 2 points that are on a diagonal. So if you look at the 2 points, and if I draw a red line from one blue point to the other, I would hope that you would know the distance between those is, let's see here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the distance between the two blue points is 11 units. Now, how did I do that? Well, I counted each line. So I started on the blue, I marked it in yellow. I went down a line, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 units. And of course I could have started at the bottom blue one and counted up and I would have gotten the same thing. So that's the first type of problem. If your 2 points are just a straight line like this, or they could even be 2 points like this, all you have to do is count the boxes, okay? So now the difference is if you look at the 2 green points, it's not as simple because if I extend a line between the 2 green points, you notice we can't count boxes because we're going through boxes, we're going through parts of boxes. So we're going to do these problems completely differently. So imagine that I took the top green dot and I extended a line vertical from it. And imagine that I took the other green dot and I drew a horizontal line from it. Notice what I have. I'm going to highlight it. Hopefully everybody can see we have a right triangle. So if we could figure out what the hypotenuse is over here, because we all know that the longest side of a right triangle is the hypotenuse, then we will know the distance between the 2 green points. So first thing we're going to do is we're going to take side A. Whoops, let's use a marker here. We're going to use side A, and we're going to figure out how long is side A. Well, if I count from here to here, it is 1, 2, 3, 4, 5, and whoops, let's count the lines. 1, 2, 3, 4, 5. I think it's 5 because I don't think I actually went on a very good spot. So A is 5. All right. Now I have to look at the other side of the triangle. I'm going to highlight it in red. We're going to call this B. And we're going to count this side. So here is my green dot. So I go 1, 2, 3, 4, 5, 6, 7, 8. So b is 8. So, of course, we know the Pythagorean theorem says a squared plus b squared equals c squared. We just figured out that a is 5, so 5 squared, and b is 8, 8 squared equals c squared. So, of course, we're going to do 5 squared is 25, 8 squared 64 equals c squared. 25 and 64 is 89 equals c squared. And, of course, the last step always of the Pythagorean theorem is we are going to take the square root, and unless you're told otherwise, we're going to round to the nearest tenth. So I should have told you, you'll need a calculator here. So when I take 89 and use my calculator and find the square root of it, I come up with 9.433981, and it goes a lot farther, but I want it to the nearest tenth, so it is going to be 9.4, and we don't have any units on this problem, so we just say 9.4 units. So the distance between my two green points was 9.4 units. So this is 9.4. So just to review, if we have 2 points that are able to be counted between each other on a straight line, all we do is count, like over here. But if we have 2 points that are diagonal, like over here, we're going to draw a right triangle and use Pythagorean theorem. Okay, so now what we're going to do is we're going to do some samples together. So what you need to do now is have some graph paper out, and I will be doing the problem along with you on the screen. So this problem would say, find the distance between the 2 points, -4, 6, and 2, -7. And of course, until I plot these 2 points on a coordinate plane, I don't have any idea if they are diagonal from each other or if they're on the same axis. Okay, so I have my coordinate plane here, and of course on your homework I will provide coordinate planes for you. So I need to plot the 2 points, so I'm going to plot them in red. So -4, 6, I start at the origin, I go 4 left, and I go 6 up. So here's my first point, -4, 6, and my second point, 2, -7, I go 2 right and 7 down. So here's my other point. So as you notice, they're diagonal, so we're going to have to use Pythagorean theorem. So what I'm going to do is I'm going to connect the 2 red points. Okay, that will always be my hypotenuse. And then from one point, I'm going to draw a horizontal line, and the other point, I'm going to draw a vertical line so that I make my right triangle. Now, please note that you could have done this too. You could have gone vertical from this point and horizontal from this point. So there's 2 triangles you can use. All right? So we are going to focus on the one that I'm going to highlight in yellow here. Okay, so what we're going to do is we're going to label this side C, this side A, and this side B. And we need to find the length of each of those sides. Except, of course, we can't do C until we do the Pythagorean theorem. So if I look at A and I count how far from here down to here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So A is 13. Okay, we're ready to count B. So I'm going to go from here to here. So that's 1, 2, 3, 4, 5, 6. So B is 6. So I'm going to go over to my workspace and I'm going to write my Pythagorean theorem. A squared plus B squared equals C squared. And yes, this is the work you're going to show. I'm going to put my A in. So I have 13 squared plus B is 6 squared equals C squared. So 13 squared is 169. 6 squared is 36 equals C squared. If I add 169 and 36, I get 205 equals C squared. And of course I have to remember to take the square root of 205, and I come up with 14.3178 dot dot dot. So if I round to the nearest tenth, C is 14.3 units. So what I just found out is my hypotenuse, or my distance between my two given points, was 14.3 units. Okay, here's my next problem. So I want to find the distance between 4, 6, and 4, negative 7. So of course I'm going to plot them first. So if I go 4 right from the origin and I go 6 up, whoops, helps to have a marker here, sorry about that. Okay, so 4 right, 6 up, it's going to be right here. And then 4 negative, whoa, that's not it. Whoops, just like in class, I wasn't paying attention. Okay, 4, 6, maybe that's where I was. Okay, 4, negative 7, sorry about that. So I'm going to go 4 right, and I'm going to go 7 down. So here's my other point. Now if you look at these two, these are not diagonal. So I don't have to use the Pythagorean theorem on this one. I just want to find out how long is this line. So all I'm going to do is count boxes. So from the top one, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my length of my line is, or between my 2 points, is 13 units. So these are the easy kind. You don't have to use the Pythagorean theorem. Okay, on this problem, what I want you to do is I want you to plot the 2 points yourself, and I want you to find the distance, and then when you're ready, watch my video and check your work. Okay, I'm going to go through the problem. So I'm going to plot negative 4, 7. So I'm going to go left 4, and I'm going to go down to 7. And then I'm going to go to 5, 3. So I'm going to go right 5 and 3 up from the origin. And they're not a straight line between the two of them. They're actually a diagonal. So I'm going to draw my line. And then I'm going to make my right triangle. So I'm going to draw a vertical line from this point, and again, remember, it doesn't matter which way you make your triangle. And I'm going to draw a horizontal line from this point. So again, if you wanted to, you could have done this one. Either way, you're going to get the same answer. Okay, I'm going to focus on the one that I made green, so I'm going to highlight my whole triangle in green. Okay, so I'm doing the green one. Alright, so I'm going to label my sides. I'm going to say this is A, this is B, and of course the diagonal side is always going to be the hypotenuse because it's the longest side. I'm ready to find the length of my side, so if I look at A and I start here, I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So A is 10. And if I look at B and I start here, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9. B is 9. So I'm ready to do the Pythagorean theorem. So I'm going to go over here and I'm going to write a squared plus b squared equals c squared. And A was 10, so I have 10 squared. B is 9. And C, that's what we're finding. So 10 squared is 100. 9 squared is 81 equals c squared. So 100 plus 81 is 181. And remember, you always have to do the final step. You got to find the square root. So when I took the square root of 181, I got c to the nearest tenth, because it was 13.45. It's going to be 13.5. And then you just put units, because we don't know what the actual units are. Sometimes we will, like if it's a real life story problem. So the distance between my 2 red points using the Pythagorean theorem is about 13.5 units. Okay, I'm going to have you do one more example. If you don't feel like you need the next example, you can go back to the e-learning day directions and see what is next after watching this video. Otherwise, go ahead and continue the video, and I'm going to do one more sample problem in case you need it. Okay, here's my last example for you. So I want you to find the distance between -3, 4 and 0, -7. So go ahead and pause the video. do this problem on your own and then come back and watch me and we'll see if we match on our answers. Alright, so I'm going to plot the points negative 3, 4. So I'm going to start at the origin. I'm going to go left 3 and I'm going to go up 4. So here's my first point. And my second point, 0, negative 7, means I start at the origin and I go down to negative 7. So they're not straight from each other. They are a diagonal. So I'm going to draw my diagonal. This one's a little harder because it's a steep triangle. Okay, I'm going to draw my right triangle. So I'm going to extend my line here and I'm going to extend my line here. And just to make it show up a little better, I am going to highlight my right triangle in red. There we go. Whoops, that wasn't a very good line. How about that? Alright, and I'm going to label this side A. Need my marker now. Whoops. Here's A. Sorry about that. My little side here is B, and then my diagonal is C. Alright, so we're ready to find out how long is A and B. So if we start on A and we start up here and we count boxes, we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So A is 11. And then if I look at B and I start here, I'm going to go 1, 2, 3. So B is 3. Okay. I'm ready to do the Pythagorean Theorem, so I'm going to do a squared plus b squared equals c squared. So 11 squared plus 3 squared equals c squared. So this is 121 plus 9 equals c squared. Now we've got 130 equals c squared, and of course the last step, take the square root. When I took the square root of 130, it's 11.40175, so to the nearest tenth, that would be 11.4 units. So my distance between my two original points, negative 3, 4, and 0, negative 7, is 11.4 units. Okay. That ends my example problems in my lesson video, so please go back to your module labeled E-Learning Day and go to the next step. Have a good day.